This recording is going to review Unit 5 on fraction sense in the Math Plus Red program. This is a very, very important unit, and as you can see, it's a rather long unit. It has 19 days or almost 4 weeks of instruction. And there's also a couple or three actual optional choice days built into this unit. So those are excellent times to review skills, to do some of the online things like Triumph Online and Study Island, and apply what you've learned in the real world. Also, sometimes the extended problem solving may take more than one day, so use one of your optional choice days if that is the case, because it is a little more complex at times and it does involve perseverance. We also have the math portfolio that was pushed out that you might want to spend some extra time on. So let's go ahead and head to the student activity guide to talk a little bit about fractions. The thing that's very, very important for students to understand is that fractions are a number. A lot of times they think of it as just a shaded part of a shape, but fractions are a number and they can be represented in many different ways. One thing that's going to be new for fourth grade this year is that there will be mixed numbers. We might have two wholes and part of a whole. So here we would have two and then there's one, two, three, 4, 5, 6, 7, 8 parts, and 5 of those parts are shaded. So we have 2 and 5/8. Here we have the entire portion shaded. This is critical for students to understand that when we have everything shaded, we have the entire whole. We can represent that as 1, or we could represent that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10. We have all 10 of the 10, which is the same thing or equivalent to one whole. As you go through, students will be encouraged to model what we just talked about, is how if you have all of the pieces, you have the entire whole. We want students to realize that the top number is the numerator. This was something they were introduced to in third grade. The numerator tells how many parts of the whole, and the bottom number is the denominator. We also want students to really understand that when you're talking about fractions, you're talking about equal shares. And even using an example of a giant size Hershey bar to a mini size Hershey bar, if I took 1/2 of the giant size Hershey bar and you took 1/2 of the mini size Hershey bar, it's not going to be the same, even though they're both halves. We have to compare things to the whole. So when we compare fractions, which we'll talk about in a little bit, we're talking about the same size whole, but also each piece within that has to be the same size. It's about equal and fair shares. So having that understanding is very, very important. We also want students to understand, and as you can see, like, a lot of these don't have equal shares, but we want students to understand that as the denominator gets bigger, students also, may think, oh, well, then you're going to have more. But as the denominator gets bigger, the pieces are cut smaller and smaller and smaller. So I would use real world situations as much as possible. When you're cutting a pie or cutting a pizza and talking about how many different shares you will have, encourage them to realize that denominator, even though it's getting larger, how the pieces get smaller and smaller and smaller. This unit or this lesson talks about the whole a lot. I'm going to show you with my document camera something that's really fun to do. When you represent something such as 9 over 9 or 5 over 5, whatever it may be, I would encourage students to really draw that 1 to say that it really is 1, because when they start finding equivalent fractions later on in this unit, realizing that they're really only multiplying by 1, which they learned back in third grade. And when you multiply something by 1, it does not change the value. So it's really important that they understand that concept, that you can have those numbers 7 over 7 or 9 over 9, but you're still representing one whole. Now we're going into sketch fractions. This is really important, especially right here on solution 3, because we want students to realize that fractions come in you can represent them differently. Here we have a shape or an area model that's shaded in. Here we have part of a set, And here we have a number line. Number lines are a big emphasis of the math program in showing fractions because this is something that they will use in the real world. We use rulers all the time. We also want students to really see that these are numbers. It's not just a shape, it's not just a quantity that you see represented like this. It can be a quantity represented as a number line. Even coins, when you think about a dollar could be the whole, and pennies are a fraction of that whole. So we want students to be able to realize that fractions are numbers and are represented in many ways. Number lines can be tricky, but we definitely want them to begin implementing them and learning how to use them to compare fractions. So as much as possible, implement these number lines. This is really tricky because it says sketch two number lines that show 26/9. Well, that's an improper fraction. But we are showing that this whole is divided into ninths, and so there's 9/9 and then 9 more ninths, and they keep going counting by ninths, and so they realize they're not quite up to 3, but they have 2 wholes and then 8/9. And so this really helps students understand that fraction can be represented as an improper fraction and turned into a mixed number, because when the number on top is bigger or the numerator is larger than the denominator, then we can convert that to a mixed number to show wholes and parts of the whole. So that is why a number line can really be helpful in that situation. Right here we have additional practice, and you can see it talks about different representations, parts of sets, parts of number lines. It says put a dot on the number line to show the mixed number 3 and 4/1/4. So we have our 3 wholes, and we can see that it is divided. Each section is divided into 4 equal parts, and we have one of those 4. So the students would place their number right here. Right here it says shade 2 of the 6 objects, or 2/6 objects, 1/3 of the apples. This could be tricky because they may say, oh, I'm just supposed to shade 1 or I'm supposed to shade 3. But they need to count the entire, they always need to think of the whole. So when thinking of fractions, make sure they always look at the whole, whether it's a number line, shapes, or something similar to this. And this is so important because when they get to 5th grade, they're going to be doing computation and multiplication with mixed numbers. So really understanding what the fractions mean is critical in 4th grade. As we go through, there's a lot of different practice opportunities using the different models. Again, this is critical for students to understand that fractions can be represented in many different ways, and just understanding what a fraction is. This unit is a big component of the standards, and in fact when they get to students get to 5th grade, the Georgia milestones, 30% of that test will deal with fractions and computation. So we want students to really understand what it means to represent a fraction and understand a fraction, especially before we start computing with them. This is an example. It says which shows 3/4 on a number line. We want them to understand, okay, look for something that's divided into 4 equal parts, and we want 3 of those 4. So here we have 1, 2, 3, 4 parts, and there is 3 of the 4. We also want them again to be able to recognize what a mixed number when we have wholes and part of the whole. And this will lead nicely into the lessons on decimals as well. When we have word problems like this, it definitely can get tricky. So don't hesitate to pull out that Learning Coach guide. That's what it's for. And you can go right to that fraction sense unit and preview this before your student does these activities. And I know it's kind of slow on my computer, so we'll go head back to this. But basically, we want students to understand that if we have, it says a plumber needs to cut a 6-foot long pipe into 10 equal pieces. How long will each piece be? We have 6 out of the 10. So we can turn that into a fraction, and we want them to understand that fractions are the same thing as a division problem. So we'll continue to go through some word problems like that and more representations. Repeated addition is something they learned with multiplication and skip counting in 2nd and 3rd grade. So this says which means the same as 2 and 1/4. So let me get my document camera out again, and I am going to model that same type of problem as we can see it. So we have 2 and 1/4. Well, if we think about this 2 right here as a whole, so I would have 4/4, and then another 4/4, plus a 1/4. Now, if we broke this apart, of course, we could have 4/4 or 1/4 plus 1/4 plus 1/4 plus 1/4. That would equal 1 whole, because we would have 4/4. And then we would have 1/4 plus 1/4 plus 1/4 plus 1/4, which would equal another whole. And then we would have an additional fourth. So using paper and models like this to really help students see that this is the same thing as 4/4 written out like this. We've added them all together, and it's good practice for them to see that the numerator or the denominator didn't change. We didn't say 4 plus 4 plus 4 plus 4. We said 1 plus 1 plus 1 plus 1. We didn't change the denominator even though we changed the numerator. So understanding this is great practice. Let's keep going through and looking at some of the different models. This is something about ratio, which is not something that your child is likely to see, but I do think it's great problem solving and discussion to talk about what fraction of this red is the black. There's different shapes, because we definitely want students to understand that, and I'll show you some models a little bit later on with pattern blocks of how something can be a part of something else. This baby shoe is only 1, but this shoe is 1, so this baby shoe is 1/4. If we were comparing the big shoe first, it would be 4/1. So that would be the tricky part. But again, this is a little more of an enrichment activity. So I would definitely just work through it with your child as you go through that lesson. What we're excited about is that soon we're going to be talking about equivalent fractions. So as you go through in this long unit, we want students to see that even though the numbers may look differently, they still represent the same amount. There are tons of resources available online. K-12 even has an app. I know it's available for an iPad. I'm not sure about other forms, but that has fraction bars where students can really see how fractions compare to each other. So right here we have 4 pieces, and we have 3 of those 4 shaded. Here we have 8 pieces and 6 of the 8 shaded. We can see that those are equivalent or the same amount. Right here we have a half shaded, and here we also have a half shaded, but it's represented as 4/8. So students need to understand that just because the numerator and the denominator change, it doesn't mean that the amount changes. They still represent the same whole. It can kind of get confusing, especially when the pieces are written differently. But this is where they're talking and really trying to show students, okay, how did this work? If we had 2/5 and then we ended up with 4/10, what did you do to change it? I can see that you've multiplied something by 2/5 to get 4/10, but what did you do to get 4/10 to still represent the same amount? So let me get out my document camera again. So we have 2/5, and we know that somehow, sorry, let me pull that down. We know that it equals 4/10, but what did we multiply to get 4/10? And I know that 5 times 2 is 10, and I know that 2 times 2 is 4. And what we want students to realize is all they have done is multiplied by that equivalent of 1. They multiplied, you always do the same thing to the numerator and the denominator. 2/5, if we multiply that by 1 whole, which we can represent as 2/2, is the same as 4/10. And this is going to be really important as they move through and begin comparing fractions and things like that as well. This says tell whether the pair of fractions are equivalent. Answer yes or no. Well, just by looking at them, they may not know. So let's look at that document camera again. So we have 2, 6, and 1/3. One thing that I would really encourage you to do with your child is, like I said, incorporate those number lines and make sure those number lines are the exact same. Because when they start comparing fractions, right now we're just on equivalent, but when they start comparing, this is going to be really important. So if we have 1/3, and here's my 0 and here's my 1, and I have to make sure, like I said, our lines are exactly the same size. So let's divide the first number line into, or this bottom one, into thirds, the best that we can. So we have 1, 2, 3. Now I know that I can divide the top one into 6. So if I have 2 of the 6 and 1 of the third, yes, I have the same amount. So you can use a number line, you can use shapes, you can use circles or rectangles to show this, or you could say, how did the third 3, let's look at the smaller number, how did that become a 6? If I multiplied by a fraction equivalent to 1, I get 2/6. So yes, we have only multiplied by 1, which means the fraction keeps its same identity. This is the identity property when we multiply by 1. It's just like looking in a mirror. When we look in a mirror, we see ourselves. So 1/3 is still seeing itself. It's just represented a little bit differently as 2/6. There are a couple of lessons on equivalent fractions, and this one is excellent because it does use those number lines and encouraging students, okay, to really think about what the numerator and the denominator would be. We have 4 equal pieces. Now we need to really discover how many equal pieces are there and what number would be here to represent 1/2. All of these are going to represent 1/2, but they're going to look very, very differently. And then here is one that talks about the area model, and these are larger fractions. You probably will not see fractions this large, but what I will show you, and again, I'll show this with my document camera. If you're given something such as 15/25, we also can not only just multiply, we can also divide. So I know that 5 will go into both of these numbers. Let me focus that a little bit better. So I'm going to divide the top by 5 and the bottom by 5, and I will get 3/5. So whether you multiply or divide by 1, you're still going to end up with an equivalent fraction. So hopefully that will help when your child sees larger numbers, that 15/25 really is the same as 3/5. There's going to be additional practice on that with larger numbers, and then we're going to get into comparing fractions. Now, the thing that can be tricky with comparing fractions, and this is something that they learned in 3rd grade, and let me get my document camera out again. Let's get a clean sheet. If we have something such as 1/4 compared to 1/8, we really want students to think about what that numerator and denominator means. We know that our numerators are the same, so we have 1 of the 4 and 1 of the 8. Students may automatically think, oh, 1/8 is bigger because the denominator is larger. But if they think about, oh no, we've cut that into 8 pieces instead of 4, they'll easily see that 1/4 is greater than 1/8, because if we have 1 of the 4 and we have that pizza, and definitely use models, that is much larger than 1 of the 8 pieces. So pull out those online virtual manipulatives, pull out your scratch paper, encourage your student to draw models in their own journal, and then talk about same numerators. I think it's important for them to write that down, that we have the same numerator. So what happens? What happens if it's the same denominator? So let's say we have 2/4 and 3/4. Well, if we think about our pizza and we have the same denominator and we have 2 of the 4 versus 3 of the 4, we know that it's going to be different based on that amount right here, how many pieces we have of the whole. So understanding these basics are going to help when they start comparing things like 7/8 and 3/4, because those numbers aren't anything similar, but they need to understand same numerators and same denominators before they start comparing fractions that have different numerators and denominators. So what the unit goes into is really showing students how to make the denominators the same, just like we talked about a second ago. So 3/5 can be turned into tenths, but we can see here that it is larger than 4/10, but we can turn those in by dividing it up into smaller pieces and still leaving it shaded. We can also use those number lines to really help compare those fractions. It's like I said, it's very tricky when there's not all the same, but we want students to look at those numbers. So we have 5/12, and they can envision, okay, if this was moved over here and this was moved over here, we are still going to have an extra piece. So even though this one's divided into 12ths, a line across here could easily be divided, like drawn across, and we could turn this into 12ths too. So we would have 4/12. Well, 5/12 is definitely bigger than 4/12. So, and I would try to draw these models if you don't want to print them out, or if you have received the materials, definitely draw a line across. Have them create equivalent fractions by dividing this pie right here or circle into the same size increments as the other. Here is a little more abstract because there are no models, but that's when we need to really have them use those equivalent fractions and draw. It says use a sketch or a number line. This is where we want kids to use that scratch paper and draw that model on their own instead of providing it for them. And remembering that one whole is the same numerator and denominator. This is a size fraction that your child is not likely to see, but it does, since they have provided a model, that definitely helps in understanding this, because even though the digits and numbers are large, you can easily see and compare. Here's 3/5, here's 45/100. We can see that 3/5 is larger, even though these numbers are a lot larger. The thing that they really want you to understand too is using benchmark numbers such as 0, 1/2, and 1. So when you're comparing fractions, think about, well, is it closer to 1? Is it closer to 1/2? Is it closer to 0? And that can help in the comparison process as well. And then we get to the core focus on fractions, and it's going to be more of the same and implementing the fractions in word problems. We definitely want students to understand that fractions are part of our everyday life. Every time we cook, even when we measure things, we use fractions on a daily basis. In addition to all of these resources in the OLS, don't forget about the elementary math web page. If you go to the 4th grade page and go to the fractions, there are additional support items for you, such as videos. There's Learn Zillion videos. There's also manipulatives that you can use online to help reinforce equivalent fractions and understanding naming the fractions. This is good practice if a child is really struggling with, well, if the denominator gets bigger, why do the pieces get smaller, and just helping them understand that. Here are some lessons on comparing fractions, and then later, as we progress through the year, we will get into more about computing with fractions, but right now we really want students to understand them. I highly recommend taking the time to watch all of these videos so that your student can see how fractions can be represented as sets on a number line and part of a shape. Also, if you go to Triumph Online and go to the bookshelf feature, some assignments have been assigned already, but fraction lessons have not. So go to the Common Core Performance Coach, and then go to equivalent fractions and comparing fractions. When you open those up, these are great opportunities to expand what your student has learned, as well as reinforce things with different types of models. As you go through the different pages, you can print these out, or you can just have your student write them in their math journal, but it totally reinforces what has been already taught and is very much aligned to the Georgia Milestones assessment. This offers a different way of responding to where students draw a line to match or circle equivalent fractions as they go through. I like that they offer yes no solutions so students, instead of just creating the equivalent fraction, they can determine is this, they may have to draw models in their notebook paper or scratch pad to determine that, but it is good for them to experience these different types of questions at these different formats. So I highly recommend that you explore that. And last but not least, I do want to share some things even on my iPad. So I'm going to turn on the document camera again. And on the iPad, I have, and I'm going to make this full screen so you can see it a little bit larger. There are tons of virtual manipulatives available, and pattern blocks are a great way to also share and about fractions. So if you pull out a shape such as a hexagon and you start to cover it with triangles, you can see that right now we have 1/2 of the hexagon covered, which would also be the same as this piece. And with some of these apps, it's really cool because you can, rotate the shapes. And it's also fun to even pull out designs such as these right here. And you can have students, move the pieces. I'm going to clear some of this and pull out a clean design. But thinking about this whole, we want students to think of fractions as part of the whole. So think about this whole shape, and they could design their shape and then use the triangles on top of that to talk about what fraction of the shape may be yellow, what fraction of the shape may be red, what fraction of the shape maybe they had to use some blue for certain things. And so I will also include some printable pattern blocks and some triangle grid paper, because making designs and then talking about the fraction of the shape, this wouldn't just be 2 are yellow, because we would need to think about what is that consistent part in all of these shapes. The red, the blue, and the yellow can all be built with green. So we would want the green to be the denominator, and then the other shapes would be the numerator. So there's tons of fun things to do with fractions. I hope you enjoy exploring them. Like I said, it is a big unit, but doing the hands-on activities and the modeling and encouraging the use of a journal or scratch pad is very, very important. Definitely take advantage of the online manipulatives. And when you go to the Learning Coach Guide, don't forget there is the resource section. So when you go to these, you will see that there are fraction story problems, grid paper, there's number lines you can print out. In other sections, there may be some fraction bars or circles that you can also print out. If not, they are definitely online. So here's fraction strips in an upcoming unit. So definitely take advantage of those resources that are available to you in the OLS. Thank you.